Now let's talk about the boundary layer theory. Now this is a very important topic and you should be very good in understanding of this topic. So let's introduce the concept to you. So let us say you have a solid body of this shape. So this is the solid body. Okay, and a real fluid is flowing across, or you can say a stream of real fluid is flowing over this solid body. Okay, so when this real fluid, so the entire velocity, let us say, is capital U, and this capital U is called the free stream velocity. Free stream velocity. Now, when this fluid passes over the surface of the body, the fluid particles, they will cling on to the surface. Okay, this means that the velocity of the fluid particles at this boundary of this surface or boundary of this body will be equal to the velocity of the body. This means that the body is not moving, the movement is of the fluid. So when I say that the velocity of these fluid particles which are on the boundary of this body will have the same velocity as that of the surface of the body, this means that the velocity of the fluid reduces to zero at the layer or at the boundary of this body. So we can make a generalization out of this, that as a real fluid flows over a solid body, fluid particles they cling on to the surface of the body, okay. This means that the velocity of these fluid particles would be same as the velocity of this surface of the body. This means velocity of the fluid particles, okay, on the surface should be equal to the velocity of the surface. This means that the velocity of the surface is zero, so the velocity of the fluid also at the surface is zero. Okay, now as you start going up or away from the surface, the velocity starts to rise. Means there is a variation in the velocity which is witnessed as we go away from the boundary of the surface or boundary of the body, the surface of the body. Okay, so this means that there is an existence of a velocity gradient, means velocity will change with respect to distance from the surface. Okay, and after a certain time or after a certain height, you will have a velocity which will no longer vary with respect to distance, means this velocity would be equal to capital U, which is the free stream velocity. So this again gives us a generalization that the velocity gradient this exists only for a small portion above the, or you can say this velocity gradient is occurring in a small layer above the surface of the body. This is occurring in a small layer, okay, above the surface, and below this or say beyond this, not below, beyond this, the velocity gradient will vanish. So this, you can say, a region in which the velocity gradient is occurring, that is, the velocity is varying with respect to the distance from the surface of the body, this small layer is called the boundary layer because it is very close to the boundary. Okay, so because there is some velocity variation with respect to distance in this boundary layer, this means there will be some production of shear stress. So the value of the shear stress in the boundary layer would be given by mu du by dy. Mu du by dy. Okay, so this means that if you go beyond this boundary layer, there will be no velocity gradient. This means there will be no production of shear stress. So there is no tau over here. So tau becomes 0 once you go beyond the boundary layer. Okay, so to summarize, I would say the fluid particles which are on the surface of the body have zero velocity, means they are at rest. This condition is called no slip condition, because there is no relative motion in between the fluid particles and the body surface. Right? They are at rest, the velocity becomes zero. As you start going away from the body surface, the velocity will start to change. This means that a velocity gradient will come into picture. Alright, and as you keep on moving further away, ultimately this velocity gradient would vanish and the entire flow would have a same velocity of the, you can say, the free stream velocity. Okay, so the height above which or up to which this gradient is occurring or this velocity variation is occurring is called the boundary layer. Within the boundary layer, because there is some du by dy occurring, so you will have some value of tau. Okay, and as you go above this boundary layer, there is no du by dy. This means the value of tau becomes 0 and the entire flow moves with a single velocity, which is the free stream velocity. So I hope you got this basic introduction of the boundary layer theory. Now let's move on to the next topic and talk about the kind of flows which occur in a boundary layer flow.